Hi, everybody. Good morning. It's the third day, and so I'm feeling a little fuzzy. I hope you guys will bear with me. I also want to apologize up front that I am not Shanker Iyer. I'm a less good version of him. Unfortunately, he was not able to make it. Shanker is an architect and engineer for a partner of Mirantis's named Bjarke. And my name is Craig Peters. I'm a product manager with Mirantis. I'm focused on enabling workloads on OpenStack, any kind of workload. So I work very closely with the Heat project, with the Murano project, Mistral, Sahara, and so forth, the kinds of projects that are all about running clusters of applications and managing those applications' life cycles in OpenStack. So what I want to share with you today is some early work we're doing in partnership with our friends at Google, and working very closely with this engineering firm called Bjarke to enable leveraging an infrastructure-aware capability, the Murano application catalog, to automatically scale infrastructure for applications. So for those of you who aren't familiar with Kubernetes, Kubernetes is a container cluster manager. So what that means is that it will take care of state for containers running in a cluster. It will guarantee that the containers can network to one another within a construct. And in Kubernetes, the logical construct for shared state and shared networking is called a pod. You essentially, as a developer of an application, you declaratively describe the number of pods you want and what containers you want to run in those pods. So there's a declarative language for doing so, and then there's a command line interface called kubectl that enables you to read those declarative configurations and run those on your infrastructure. So what we've done is we've made that extremely easy to do by adding it to an application catalog that's exposed through Horizon and also through an API. The OpenStack project that enables that is called Murano. So I'm not going to spend too much time dwelling on Murano. What I'm going to focus on is the use case that we're after here. So the use case here is you have this cluster controller, and what you want as a developer is a really easy way to take advantage of your underlying infrastructure to expose this package. It's a way essentially to pluggably add application capabilities to your cloud to manage Kubernetes clusters on that cloud. And then you want to make that sensitive to the workload that's running on it. So as a declarative framework, Kubernetes doesn't have any semantics for understanding the load on it. Essentially, it will do things like if a pod is unreachable, then Kubernetes will spin up another pod so that you have the number of pods that you declare in your replication controller. Now, if the load of your system goes up, you want to automatically trigger creating new pods. So we've essentially automated that by leveraging the Container Advisor, C-Advisor project in Kubernetes. We monitor that data. Then we, once you set some thresholds, we'll scale up and scale down the number of pods in the replication controller to take advantage of that. Once the underlying infrastructure thresholds are met, so say, for example, you want to monitor for disk space or a CPU threshold, you can set those thresholds. The monitor will then automatically trigger Murano to add additional underlying infrastructure. So what we're going to do is we're going to walk through the process of configuring a cluster. So here we're creating a new environment in Murano in which to run the cluster controller. So this is that kind of plugin for OpenStack. I'm dragging and dropping the Kubernetes cluster manager configuration into this environment. I'm setting the number of replication controllers. Now I'm setting the thresholds that I want. So I'm essentially setting there's a listener essentially that looks at the monitoring data, periodically checks it against the thresholds. Based on whether or not it's met the threshold or not, it will scale up or scale down the underlying infrastructure. So then once I've got this set up, I'm just doing this basic UI configuration. It's extremely straightforward. So Murano essentially allows me to put this in a Horizon UI, or I can call it from another portal via an API. Once that is set up, then now I'm going to go and describe what kind of flavor that I want these resources to be run on, the key pairs. So if I need to, for example, SSH into those machines for some other reason, like I want to remotely use the kube control commands. So then I'm going to deploy this cluster. Once I've deployed this cluster, I'm going to go and generate some load. So I'm just getting the IP address. I'm going to use a command line control to get some load. So first thing I'm going to do is I'm going to take a look at what the load is on those machines right now. So I'm going to tail the log so we can watch the load on those machines. I've set the threshold very low so that we can really easily show it scaling up and down. So I can see the load here is very low. Right, now it's jumped up. So the load on it has increased below the threshold or above the threshold. It's triggered the scale up action. So it's using the Murano API to automatically provision additional resources. Those resources are automatically added to that environment. So I can see it's created a new virtual machine, a new minion or worker in the Kubernetes cluster. It's deployed and now spread my pods across those, and now the load is decreased below that threshold. Now that it's below that threshold, it's going to reclaim those resources. So what I've got is the ability, without knowing anything about Kubernetes, I, as a developer, can very quickly configure a cluster to be dynamic the way we want it. So the point of having this in a configuration like Murano is that I have control as a developer about how my infrastructure behaves. I can then, for whoever wants to be operating a cloud, I can make this available essentially as a cluster manager as a service to any other developer in my community. I can configure through the UI in Murano what the inputs and outputs are, what are the parameters. As an operator, then I can have control over what control the developer should have there. And this can then be repeatable through the API. You can drive this through your continuous integration workflows, doing tests of your applications. And that way, you've got the infrastructure to have rapid delivery of very sophisticated clustered applications across your clouds, and you can deploy these in any one of your clouds with a lot of control. The next thing we're working on is scaling this across a public and private cloud. So essentially, we're going to automatically create a VPC in a public cloud. We're working initially with the Google Cloud Engine folks. We'll carve out resources there automatically, spin up pods, and add those to the replication controller. The workload will be spread there, and then when those resources are no longer needed, they'll be freed up. And so the cluster will then be running locally. What this does, the way this works is in Murano, we essentially are creating these packages. We're contributing them all upstream in our GitHub repo. Any of you can take them, understand how to manage a Kubernetes cluster in a dynamic way on your cloud, and help us understand how you would take advantage of it, collaborate with us to add capabilities to it. So what I invite you to do is to go to apps.openstack.org. Check out the Kubernetes package there. It'll also have a pointer in apps.openstack.org to the GitHub repo. Take a look at that. Try it out in your cloud. I also invite you to do this on your own environment. If you are interested in Murano, it's very easy to get Mirantis OpenStack, download it. Through a GUI, you can just deploy Murano into your cloud, and you'll then have the ability to add this kind of pluggable application infrastructure management into your cloud. So I think I have a couple minutes if there are any questions. If there are not, thank you very much.